Hi, I'm Jack Baker. This presentation is part two of a two-part presentation. I want to talk some more about giving effective technical presentations, and here at this part I'm going to focus exclusively on the graphics side of things. So the motivation for this is that the graphics are really probably the most critical part of our presentation. They're certainly the most information rich. That's where the data is getting conveyed and where the story is being told. And unfortunately, what I've seen is, especially in technical fields, I think many people are not very thoughtful about using their graphics. They have some numbers, they make a plot that includes those numbers, and they put it up on the screen and don't think much more about it. And I think it's really a lost opportunity and counterproductive for a lot of technical presentations. So I want to think a little bit more carefully about this. And just to illustrate, there's a couple figures on the screen. We'll talk about these in a little more detail in a few minutes, but it's the same data on the left figure and the right figure, just with two different sets of decisions made about how to display it. And even the figure type is identical, the aspect ratio is almost identical. So it's really just some minor details in the way things are presented. But I would expect you would agree that the figure on the right side is much more legible and understandable and tells a story much more than the figure on the left side. And so we just want to think a little more carefully about how that right side figure could come about, how you can make figures that look like the right side figure rather than the left side figure. A couple caveats on this. I'm by no means an expert on graphics or graphical design, but I've read some books by experts and I just pay attention to this issue. I should also say I'm an engineer. I don't have any real graphic talent. Further, I'm colorblind, so I can't even tell apart some of the colors in some figures. So I'm not one who's going to make stunning award-winning graphics necessarily. But I think the thing that distinguishes me and why I feel qualified to give a presentation about this is that I think a lot about how a viewer is going to see a figure and perceive a figure. And because I think a lot about the viewer's perspective, I think I have more to offer about how to design these figures so that it's effective from the viewer's perspective, which is really the most important thing, I think. Okay, so let me tell you about how I propose you create a graphic. This is basically what I do when I make graphics for my presentation. So first of all, we got to think about the message, right? What am I trying to convey when I show this figure? And if I don't know what I'm trying to convey, then I'm kind of lost right out of the gate in terms of coming up with an effective figure. Once I want to know what I want to convey, then step two is going to be to pick a type of figure. How am I going to, what's going to be the layout of this figure? And what kind of elements do I need in that figure to help tell this message? Once I've got then I've got a plan of, okay, this type of figure might work. I'll make a draft, take a look at that. Then I'll check some formatting stuff. We'll talk about that, just in my labeling things clearly and things like that. And then I iterate. So it's very rare that the very first draft of a figure is the right one. So I look at it, then I refine it, try it out a little bit, and then show it to other people, importantly, and say, do you understand what I'm trying to say? Is this confusing, or is your eye drawn to something that other than what I wanted? Because there's iterations here. And then I might go back up to, oftentimes I don't change the message, but I might go back up to step two and kind of pick a different figure type or pick some different elements to better convey what I'm intending if the first draft didn't work very well. Okay, so that's kind of my general process, and then let's talk about a couple specifics here to help us through that process. So I want to talk about kind of what are the characteristics of good graphics, what are some types of figures we can choose from for that step two, and then I want to talk about making comparisons. I think that's an important part of our message very often, and there's a few ways we can make comparisons effectively. So good figures, what makes a good figure? So I think there's two things we want to think about before we can evaluate if we've got a good figure or not. So one is that message, right? What are we trying to convey? And then number two, is that message going to be clear to our audience, right? And if the audience clearly gets what we're trying to say, then we've got a good figure. If the audience doesn't know what we're trying to say, or if we don't know what we're trying to say, then we're in trouble, right? And so I oftentimes have a situation where a student will come in, they've got a figure, something like this, and say, what do you think of this figure? Well, I almost always say, well, that depends. All right, and it depends on a couple questions, right? What's your message, and who's your audience, right? And I could guess what the message is, and sometimes that's actually useful. So if I guess what the message is and I guess correctly, that's a good sign. And then we also want to know about our audience. So is our audience going to be able to guess in the same way as I do? Because people have a variety of perspectives they bring to problems and a variety of biases and assumptions. And if we don't understand that audience's assumptions, and then we're going to potentially be in trouble. So let's talk about that a little bit more. So making sure that message is clear. So got a picture here just to think about clear messages. And so you can look at that for a second. I've got the source where I took the figure from, and I'll note that it's an optical illusions website. So that's even an extra hint. And the thing I want to bring up with this message is that basically our minds, they don't process kind of raw data and raw pixels, right? Our minds process images and they look for patterns, and we identify patterns and come up with a story based on that, right? And we're amazingly successful as a species because of all this computational power we have to do that, processing power. But it can also be dangerous for you as a technical presenter, because if the audience is finding some pattern that's not the pattern you want them to see, they may be off on a completely different track than you're intending, and they may totally miss your message, or may actually take away a message counter to what you're trying to tell them. And unless you're kind of aware of that potential, then you risk big problems, right? And I think that I see that a lot, because people will put some sort of figure up on the screen, and they have some sort of intention that they assume the audience is going to get out of it, and the audience isn't able to perceive that, or because of there's some confusion, they come up with something else. So what's that have to do with this picture? So you've been staring at this for a while, right? It's a picture of a rose, correct? And that's, our mind looks at this, we say, oh, there's a rose, excellent, everything looks good. There must be some sort of a story about a rose. And the interesting thing is that right in the middle of the figure, probably not very many of you noticed, there is a dolphin kind of superimposed in this figure, right? And so that dolphin is sitting in there. Let me take off the line again. So I think probably also for many of you, if you're still staring at this figure, you can easily see the dolphin now. But just a few seconds ago, probably most of you did not see that dolphin, right? And that's the power of our mind to kind of recognize the pattern of the rose. Okay, we know it's a rose, we can move on. We don't waste a bunch of computing power in our brain trying to figure out something else, because why would there be a dolphin in a rose? And the analogy, I hope it's clear, is that if you're up here giving a technical presentation and talking about a dolphin, and your audience thinks you're talking about a rose, you're in trouble, right? And so if I need to explain to you what to be looking at in my graphic, I probably haven't made a very good graphic yet, right? And I think that there's a line that I like, I've heard a few times, which is, I'll see it when I believe it, right? If I believe this is a rose, I see a rose. And if I believe it's a dolphin, I see a dolphin. So it's not that the image is giving me information that sets my beliefs. If I have some sort of belief, I'm going to see what I believe, right? So we got to be careful of that, or just be sensitive to that with our audience. Okay, so back into kind of some technical details, right? We want to make sure that our figure tells the story we're trying to tell. Make sure that the audience, we want them to see the rose, not the dolphin, that kind of thing. So what do we want to do? We want to, figure out a figure type, which can help tell that story. We want, there's some key features. So there's something we're trying to tell the audience, and we want to make sure those are clear. Think about kind of the axes on our plots. I'm thinking a lot about numerical data in this presentation. That's really common in technical presentations, but some of these principles apply more generally. Then you want to make sure your data is really front and center. You don't want to have other sorts of distracting stuff that's taking your audience's attention. And you want to use big, clear fonts, plain language labels. Just make sure it's super clear to the audience what exactly you're plotting, what are the values, and make sure they can understand the quantities that are being discussed. So let's get into a little bit of detail on that. So here's what I would consider to be a good figure in terms of those elements on the previous slide. So let me ask you, I'm going to pause for a second, kind of what is the message of this figure? So if you stared at that for a couple seconds, I hope what you took away is, and you don't have to be a domain expert in any of these parameters. This is actually just made up data, but I want to illustrate because it's kind of realistic. What I would hope you would take away is that at the left side of the figure, so first of all, there's three sets of data being plotted. There's alternative 1, alternative 2, and a proposed approach, whatever those are. And at the left side of the figure, for the lower values of peak ground acceleration, all three of them are kind of similar. And then on the right half, or the right third of the figure, the proposed approach is giving lower displacements, lower maximum displacements than the other two alternatives, right? And we still have, lots of unresolved questions. Just because this is a clear figure doesn't mean that my, the way that I came up with these data are good, or that my, final conclusion in the paper is good, or anything like that. But the key is that whatever my data are here, I'm conveying that clearly so that I can make my case, right? That's what we're really focused on. And what I want to think about is kind of what makes this figure effective, right? And when a figure is effective at showing you the information, you almost don't even notice what elements are making it good. And then conversely, I think too many engineers see bad figures and they're patient in tolerating the deficiencies without even noticing them. I think there's a lot of ways we could screw up this figure, and many people just kind of tolerate it. They don't even think about it, right? Partly we don't have control over other people's presentations unless we talk to them about it. But we should still be cognizant of deficiencies so that we're not making the same mistakes in our own presentations. So in contrast, this is another version of that same figure. So it's the same numerical values and just plotted differently. And so this isn't really a joke. I think I've seen quite a few figures like this in papers and presentations. So all of these things that I've done differently in this figure are things that I've seen in the real world. So I don't think I'm being unfair in raising this as an example. So if somebody brought this into a presentation, I'm going to ask you, and then I'm going to let you think about it for a few seconds. So what is bad about this figure, or what makes this figure less effective than the previous version? Okay, so, and you can pause this for a few more seconds if you want to look at it some more, but I won't continue running the video. So a few different things. Let me highlight some things. So one, the axes labels. I've got an acronym down here. I've got some sort of a informal abbreviation on the vertical axis, MAX, DISP, whatever that is. And so unless you know exactly what I'm doing, you probably don't know these values, or you had to pay very close attention when I introduced these, even if I did introduce them in the presentation. And I also have a legend up here that's got kind of I've got some abbreviations in some of these legend entries, so you're going to have to decipher what those things mean as well. Then when it comes to the actual data on the slide, or on the figure, the line styles are not very distinct, right? So when I've got kind of a dashed line and a dashed line, so when kind of one line's crossing and the other, it's not going to be all visually, jumping out at you, kind of which one's which. If I want to go figure out, okay, this dash dot line down at the bottom, this is kind of the lower valued one down here. I'm going to have to come up to this legend and kind of feed through this legend entries to figure out which one that is. And it's PROP, whatever that is. And so I've got to do a lot of work to kind of map back and forth between that legend and the line here, even if I can track kind of which line's which. The legend is out of order with the kind of the order of the line, so that makes it even harder to fish around in there. And then overall, the font sizes are really small in this figure. So certainly if you're watching this on your phone, you can probably not even read this or barely read it. And even if it's up on a big screen, you're going to have a hard time reading some of this because the text is quite small. So lots of things that went wrong here. But again, nothing that's unprecedented. We see these things a lot. A lot of these problems just come from the default settings in the software that we're using to make our figures. And it's just a kind of a lack of thinking about whether we should change the defaults. Okay, so let's do a little more direct comparison. So on the left, I've got the bad figure, and on the right, I've got the same figure cleaned up a lot. And so let's look at it more positively. Instead of looking at the bad things about that left figure, what was so good about this figure on the right that made it good? All right, so I don't have any acronyms or abbreviations. So instead of writing PGA, I can just spell out peak ground acceleration, and then the audience can immediately see what that is. Instead of writing MAX DISP, I've got kind of maximum displacement written out. I've also got units on these things so that somebody can figure out what my units are that I'm plotting. And notice, there's no difficulty at all in spelling these things out. I've got plenty of real estate along the side of the figure and the top of the figure. I didn't run out of room to write these labels, even though they're somewhat long. So there's really no reason to be using acronyms or abbreviations most of the time, especially in axis labels. But even if it is hard to use them, we should do it so that the audience can understand what we're doing. But oftentimes it's not even hard. Okay, what else? So then on the right figure, I've got distinct line styles, right? So I think to me, the red and blue and black are much easier to distinguish than the dashed line and the solid line over here on the left. And I would say generally colors are easier to distinguish than line styles. We'll talk about that a little bit more later. The other thing that is really easy on the right side versus the left side is that on the right side, I just directly labeled the lines. I just put text next to the lines instead of putting a legend in on the left, all right? So now instead of having to, on the left, where you have to look back and forth to the legend to figure out which line is which, on the right, it's super easy. I just look next to the line for the label to tell me what that line is representing. Right? And I can even do things like put the label in the same color as the line to really make sure that the pairing is clear. And I should note, again, the legend, that's kind of a default setting in some plotting software. But notice, especially if you're making a presentation, a graphic presentation in software like PowerPoint, you don't have to use the plotting software to come up with these labels. It's fair game to just put a text label right on top of your graphic inside of PowerPoint. It doesn't have to be in the original graphic. So it's not a super difficult thing to do this. Of course, there's more clever and more elegant ways to do it as well if you've got the time and the experience to do that. But don't feel like you need to come up with you have to switch software programs or something in order to label your lines directly. Just put a text box in your PowerPoint slide and label your line, and you'll be ready to go. The other thing that's pretty obvious between the left figure and the right figure is the text is much bigger on the right side than on the left side. And what I want to aim for is that the text in my figures is kind of comparable in size to the other text on my slides, right? So I would never put a bullet point list or a title on a PowerPoint slide that has fonts like in that left figure. That's just tiny, right? And so why would I make a figure with tiny fonts like that? And I think it's really just because lots of software has tiny fonts by default. So just change the font size in your figure in your plotting software, and that'll resolve that. Okay, so let's talk about figure types a little bit. So the last few slides we've just been talking about basic elements and just make them clear. But I think a more intellectual question is how should I lay out my figure, right? What should the type of figure be to convey my story? So we got a variety of options. Let me just quickly list them, and we'll talk in a little more detail, right? I could have a line chart. That's what I use probably the most frequently. A scatter plot can be good if I've got distinct data. A bar chart works for categorical data especially. Pie charts are pretty bad. I'm just going to raise it only so I can tell you not to use them. And maps is kind of a whole special category. We won't even get into that because there's lots of extra concepts and details associated with maps. But if you've got a spatial component to your data, then of course maps are an important element. So let's talk about line charts. So I think here, I answer line chart for my style if the type of story I'm trying to convey is that there's a value I'm interested in that I can compare to some sort of interesting variable, right? So in this case, it would be, say, I want to compare these maximum displacements, and they vary as a function of peak ground acceleration. So that would be an argument to say, well, let me put this data as lines. I'll plot, the horizontal axis value versus the vertical axis value. And what's nice about a line chart is it's really easy to put multiple cases on the same figure, right? So I've got 3 lines on here for 3 different cases, 2 alternatives, and something I'm proposing. And it's easy for the reader or the viewer to see what's different among those different cases, all right? And when we draw a line, we're connecting, coordinates in space. And so there's an implication that there's some sort of a continuous trend generally. And it's not that the trend is deterministic or perfect necessarily, but there's an implicit kind of interpolation between XY coordinates here when I connect things up with a line. Let's contrast that with a scatter plot. So a scatter plot is the same type of thing where I've got an X and a Y coordinate, and there's an interesting relationship between the two. But I'm going to plot as points instead of lines in this case. So I've got circles plotted here instead of lines that are connected up. And I think the distinction to make is I would use a scatter plot if each data point is a unique observation and there's no sort of continuous trend between them. So if I can't naturally connect the dots with a line, then I don't want to connect the dots. If there is some conceptual connecting of the dots, then I think it's generally easier and better to connect the dots and show the line so that the pattern becomes more apparent. So a lot of times we'll use scatter plots if we have kind of experimental data or some sort of data, observational data collected, where each circle is one observation. And I might have this type of trend where there's uncertainty in this case, say the strength value for a given displacement. So I can't necessarily connect lines between these dots, but I want to plot them versus some predictor variable so that I can see some sort of a trend. So just to think a little more about line charts versus scatter plots. So both of them can potentially have the same axes. Here I've got 2 versions of a figure with the same axes. It's the same numerical values. On the left case, I've connected the dots with a line, and on the right case, I just have the data points as independent circles. So, I think the left case is easier for a viewer to look at it and kind of see what the general pattern is, especially if there gets to be a lot of data points. The right case might be appropriate if if I think connecting those dots somehow misconstrues the nature of the data. So if I really have collected independent observations and I think I don't necessarily think it's the case that in between those circles there is an interpolation that can be done, then I might prefer the right case. In this case where there's a relatively continuous trend, I think I'd default towards a line plot versus a scatter plot, but that would be something for you to decide in a particular case. Either way, whether it's a scatter plot or a line plot, I think you got to think about the axes and make sure that both coordinates are meaningful. So I see figures like this reasonably often where somebody repeats a set of analyses and has, so in this case there's say 40 analyses and there's 40 outcomes from the calculations, and somebody will come with a figure like this and say, well, here's my 40 analyses and my outcomes, and here's my figure. And say, well, what's the message here, right? And the intended message might be something like, I performed 40 analyses and the average outcome is 0.2, right? So there's a 0.2 and kind of that's about what was typical. And I'll generally ask, well, is there something about this ordering on the horizontal axis that's useful? And if there was something that was evolving from kind of analysis to analysis, like perhaps this is an appropriate way to do it. A lot of times it's just, no, I just did 40 different analyses and those are my 40 answers. And so then I'll raise the point, well, why are you putting the analysis number on the horizontal axis? That's not a number that's meaningful, right? I don't care about 15 versus 27 in terms of some sort of trend. I also, in a case like that, I don't know that I would connect the circles with lines either, since they're separate analyses, but that's kind of a second order issue. The first order issue is the horizontal axis may not be meaningful. And if it's not, then maybe we can just say the message in words, or maybe there's some other type of figure that would more interestingly convey it. But putting the analysis number as an axis is probably not a useful thing in a case like this. Okay, third type of chart. So we've got line charts and scatter charts. A third type of chart that gets used reasonably frequently is a bar chart. So I would say a couple ways to think about bar charts that are useful. So one is if I've got categorical data, right? If my data are not numerically valued, then it can be hard to plot them on axes in the previous two versions. So this lower left figure, this is an example where I've got kind of non-insured asset losses, and then I've got kind of 5 different analysis cases. And this was a figure that the student did a nice job putting together with a kind of a gray bar to indicate a reference case, and then the colored bars indicating kind of a similar numerical value in 4 different other analysis cases. And so you can do comparisons and see, the blue bar is a little lower than the gray bar, and that would be part of the message that came out of the story. You can also compare across a couple different cases in terms of these metrics. So, it's possible to make comparisons by looking at heights of bars. I don't have to have kind of numerical values on my horizontal axis, which was part of the reason that motivated this particular figure. Thing to keep in mind is that these bar charts sometimes are not very data rich. So in this case, this bar chart only has 10 numbers in it. And I think this was a case where the figure turned out well, but just keep in mind that there's not a lot of numbers in this chart for kind of how much ink is here. And so we want to be kind of careful about thinking about those types of things. Another situation where bar charts are useful are in making histograms. So this is a case where there's some sort of horizontal axis value, and then we've got a set of observational data, and then the vertical axis is the number of observations. So the height of the bar chart indicates kind of how many observations we have. Because histograms are such a common figure, this is a good candidate for a bar chart, even though there's other ways to plot it. Because your viewer has an expectation. It's kind of like the rows. If you have an expectation of seeing kind of data around uncertainties, a histogram is a typical way to do it. So if you show a histogram, it's very easy for your audience to understand what you're doing. And so certainly take advantage of those kind of mental constructs. Okay, a pie chart. So I can't think of a case in my career where I've ever used one of these in 20 years. And basically it comes down to like, what message are you going to give people? What story can you tell out of this, right? So we could imagine, this is just an example. This is out of Microsoft Excel's kind of defaults. So I might imagine saying something like, well, source 2 is, has a bigger contribution than source 4, right? If I'm comparing 19% versus 12%. But the problem is like the idea is that the width of these pie slices indicates kind of how much contribution these things are making. But But because the pie slices are oriented in different directions, it's very hard to make those comparisons actually. And so, even this 12% versus this 12%, we may not, easily be able to tell. If I didn't have those labels on there, you may not easily be able to tell which one's bigger because they're rotated. All right, the thing I certainly can tell is that source 3 has the biggest contribution, but I could just say that in words as well. I don't, this figure's only got 5 numbers on it, and it's got a lot of different elements and labels and things. And so I think these tend to be very data poor. They tend to be kind of misleading or confusing in terms of the comparisons that are being made. So I think we've already spent too long on this, but the message is don't use pie charts almost ever. I'm sure there's a few special cases where you might make an argument for it, but if you just avoid pie charts completely, I don't think you're going to miss out on too many opportunities. Okay, so those are some kind of main categories of charts. There's many more ways to do it. So here I've taken some other figures which were, I think, reasonably effective from students. To be fair, these were from papers rather than presentations mostly. So there's a little more time to look at them. You can tell very rich stories with other types of layouts of variables and labels and coloring and things like that. The thing I would mention is just to make sure that your message is clear. So in all these cases, I think there was an interesting story to be told, and the figure kind of was driven by some sort of rich data and story to be told. The trade-off is that if you use a non-standard figure, you're going to have to spend some time explaining to your audience what they're seeing, right? So if I just do a simple scatter plot or a line plot with 2 coordinates and I put a line on it or some data points, the audience is going to understand what I'm showing. And so I don't have to explain to them kind of the structure of the figure. All I have to do is explain to them what the data in the figure are indicating. If I go to a non-traditional figure type like one of these, I have to first explain what the figure is showing and how it's laid out. Then I can explain my message. And that may well be worth it, but I want to be conscious about that. I don't want to just kind of accidentally wander into that. And I don't want to make up a new figure type just for the sake of being creative, because I'm going to hinder my audience's ability to get that message quickly. Again, think back to that rose in the dolphin. Right? The more I come up with an innovative layout of a figure, the bigger chance I'm going to have that when I'm trying to talk about the dolphin, the audience is going to see something else like a rose. So just be careful, but certainly I don't mean out of this presentation to imply that there's only 4 types of figures you can make. Okay, once I've got a figure type, a scatter plot or a line plot or something like that, I've got a lot of elements I can put into these figures, colors and styles and shapes and sizes. And we want to use all of these things. They're elements that we can use to help tell our story, but we want to understand how to effectively use them, okay? So all of these things can be used in figures to distinguish data. So this is kind of 4 versions of the same figure. And I've got two sets of data in each figure, and I've used different elements in each. Right? So in the upper left corner, I've used color. So I've got red data and I've got blue data, and you can see the difference. In the upper right corner, I've used different symbols. Right? So one set of data has a circle for the symbol, and one set of data has a little star for the symbol. In the lower left corner, I've used size to distinguish between the two. So one set of data has big circles, and one set of data has small circles. And then you can get creative. There's all sorts of other things you can do too. So in the bottom right, I've used a blur to distinguish. So material 1 has a sharp line and material 2 has a blurred line, and you can distinguish between those. And I think the message here is, these figures are a little bit small, but still, if you stare at them, you can distinguish 2 sets of data, but some of them are a little easier to distinguish than others. So to me, color is the easiest to distinguish. The top left figure, it's the easiest to just look and instantly see kind of 2 sets of data and see 2 different trends. Among the other cases, probably to me, the lower left case, the small versus the big symbols is the next easiest to see. But you can see some things are a little more subtle than others. If I use different symbols, like in the top right, it depends on what kinds of symbols I use. So some symbols can look very similar, and some are a little more distinct looking. So keep that in mind. And then we can mix and match, right? So here's a case where you could think about using color to distinguish the materials. So this is the same data as the previous slide. So I've got red and blue for 2 sets of data. And then I have circles to indicate kind of my measurements, and then lines to indicate a model that I built around that data, right? So then you've got kind of 4 sets of data, but the pairing is pretty clear. I can see red circles with red lines and blue circles with blue lines. And then that's a pretty typical convention that, measurements are plotted with scatter plots, and then a model that would be a continuous prediction as a function of displacement in this case, that would be plotted with a line. And so, here I've used kind of symbols and colors to make my distinctions. The other thing is you can use color as a third dimension. So if you've got two dimensions getting plotted, let's say on this right figure, I've got a kind of a horizontal axis dimension, variable, and a vertical axis variable. If there's a third variable that's interesting, I could use color. So in this case, I've got kind of points of individual observations, and then I've got kind of light colors versus dark colors indicating a third parameter, which in this case was kind of the standard deviation of some measurements. And so lighter colors were indicating more uncertain cases. And so you can see how the two plotted axes interact with a third variable through color. And a lot of times I think that works better than plotting a 3D plot where the kind of perspective is hard sometimes for the reader to see. Color is also really useful in indicating values when you make a map. So here's kind of a map with circles indicating places with measurements, and kind of warm colors indicating higher values and cool colors indicating lower values. So that's also a typical way to indicate values with color. And because with a map, you're already using your two coordinates, Cartesian coordinates, to indicate location. If you've got a value you want to bring along with that, color is a typical choice there. Okay. The other thing is, we can use these elements to distinguish, so I can distinguish values or distinguish between data sets. You can also use these elements to draw attention to specific data. So here's an example where I've got something a little tricky here, that I've got a H variable that I didn't spell out exactly what that is, but let's assume from context you knew what H was on the horizontal axis, plotted versus a number of station pairs. And in this case, I've got a lot of data. And the thing I don't want to do, which is the default in a lot of software programs, is I don't want to plot each data set with a different color, because then I'll end up with 500 different colors on this thing and it'll be totally incomprehensible. But if I want to draw out a couple specific cases, so I've got in this case, a couple heavier, darker colored lines for some specific cases, I can call those out, and then I can put everything else in a more subtle color or a lighter line so that it doesn't jump out, right? And then my story could be to talk about these blue and red cases and talk about, how do they relate to the broader data set or to the other cases, and I can tell a story that way. So don't feel obliged to label every single individual data set if that's not part of your message. You can just call out the specific data you want to talk about and use some other elements to de-emphasize the other data sets. Those types of decisions are totally fine, depending on your message. Okay, so we got kind of some, we've talked for a few minutes about elements of charts, the color and the lines and the symbols and things like that. We've talked about types of charts. And then once we've picked, I think those are our big kind of conceptual decisions. Then once we're actually building the figure, we need to be thinking carefully. And I would say probably the most important thing to think about is your labels, right? Super critical that you got everything labeled clearly. I can't tell you how many hundreds of times I've seen, most often when people are hand sketching a figure or drawing on a whiteboard, they'll draw up a horizontal and a vertical axis and they'll draw some data on it, and they won't label their axes, or they won't label kind of what their data is. And then the figure is almost worthless, right? This happens in presentations a little bit less often, where people don't label their axes, but you also need to, so axes labels get, a little more reliable, but then also data labels are needed too. And data labels can be done well or not well, right? So in this case, I've got a figure. The axes labels are pretty good. They're big, they're spelled out. No acronyms, no abbreviations. The data labels are the problem, right? So I've got ALT1, so that could be like alternative or alternate or something like that. Why not just spell it out? There's all sorts of real estate for it. I've got these things, so I guess that's the first message out of this one. The second thing is that, putting these data in a legend rather than right next to the lines, I think is a missed opportunity, right? We talked about that earlier. To me, the direct labels are really probably the most effective, especially in a presentation. In a paper, sometimes legends are more justifiable, but in a presentation where the audience really needs to quickly understand what you're doing, forcing them kind of back and forth is a problem. So I think direct labels are usually the most effective. I just grabbed a couple figures from various documents I've had over the years, some from students, some from myself. And, generally I think just putting some text right on the figure with an arrow pointing to it is a way for people to really quickly see kind of what you're trying to get at. And, in terms of trying to see what you're trying to get at, a lot of times what we're trying to have the audience understand is some sort of comparison, right? I want to say, well, if we did that, here would be the result. If we did this other thing, the result would change, right? I've got a new material that's going to perform better, or I've got a new analysis technique that's faster, right? And you need to help the audience member see, why are you drawing that conclusion? What's better or what's faster? And you want to show them some data to make it obvious to them what's going on. And so you want to make that comparison as easy as possible. And unfortunately, what happens is that people accidentally make their audience work really hard because they didn't think about how to make these comparisons easy. So some things that do not work well, or that make your audience work harder to figure out what your comparison is if you put your results on separate figures or separate slides. So separate slides is the worst, right? So that'll happen sometimes. I'll see that, or somebody will say, and here's my new results. This is the strength of my material. It's 12. And if you remember from 4 slides ago, the strength used to be 8. You're like, well, if you want me to compare the old results to the new results, why are you putting them on separate slides, right? I can't compare those things. I almost certainly didn't remember what you were talking about 4 slides ago, or maybe I remembered the concept but not the value. You're doing better if you get them on the same slide, but if it's in separate figures, it's still hard to compare. We'll look at that in a second. Those acronyms and abbreviations, again, the audience is going to stop listening to you and start trying to remember what that acronym stands for. And if they're lucky, they figure it out, but they missed what you were saying. If you're unlucky, they won't even figure it out and they won't know what you're talking about. And then when those legends, right? So legends in general are tricky instead of direct labels. If you do have a legend, having the legend entries out of order with the lines just makes it a lot of extra work for the reader or the audience member to understand what you're talking about. So let's talk about some comparisons, right? So here's one way I could take some data and make a comparison. So I could, I won't be mean enough to put things on separate slides, but if we look at this one and I say, okay, I've got alternative 1, alternative 2, and I want you to understand which one has bigger displacements for a given peak ground acceleration. All right, so there's 2 problems here. So one is they're on separate figures, so I can't compare the red line versus the blue line. The other thing that's really a bad idea is that I've got different, if I want somebody to compare displacements, and I've got on the left side, I've got displacements that run from 0 to 1, and then on the right side, I've got displacements that run from 0 to greater than 1.2, it's really hard to make this comparison, right? So if I look really closely, I see that over on the right side, I've got a displacement value of something like 1.1, whereas over here on the left side, I've got a value of something like 0.8, if I read it off this axis. But because these vertical axes are at different scales, visually it's not jumping out that the right case is 30% higher than the left case. So separate figures, separate axis limits is really a pretty terrible strategy for this case. Right? So we could do a little better. Here I've got the axes limits fixed, so at least they both go from 0 to 1.2. I also spelled out the names of these lines and put them right next to the line instead of having legends up in the corner. And so hopefully you agree with me that is a much more, it's much easier to visually process that than it is to process this case. Even though the layouts are almost identical, just those 2 little changes made things a lot easier. And now visually I can see that blue line is a little higher than the red line over on the right-hand side. But it still begs the question, like, why not just put those on the same slide, right? So I could put them on the same slide like this. So now I can see the blue line is higher than the red line at the right side of the figure. I still have to go say, okay, well, I see that this is higher. Now my eye has to go over here. I got to go look at this list and see, okay, the blue line is alternative 2. So, okay, alternative 2 is the higher case. All right, so there's still a little extra work, and visually, everybody in your audience's eyes is going to be doing that kind of thing. If I just make a slight change, it's the same data over here. I say, okay, the blue line is bigger than the red line. I see that. And I see, okay, that's alternative 2. So alternative 2 has bigger displacements. Right, that's a much easier operation for the audience to do. And keeping in mind, your audience, most of them have probably never seen this figure before. This is one of many different things you're asking them to interpret through the process of listening to your presentation. This figure is going to be on the screen for, on the order of a minute maybe. So they don't have a lot of time to process it. And keep in mind that besides just looking at this one line being higher than the other, they need to come down and they need to read the axis labels, figure out what you're plotting. They need to look at the limits and see kind of, when these displacements are different, kind of how big is the peak ground acceleration. There's lots of other stuff that they're looking at here. And so, you need to make it, you don't want to waste, seconds and waste their, attention by trying to make them do extra sorts of comparisons or, extra work to figure out the comparison. Just make it nice and easy, stack your data, label it directly, and everything will go much more cleanly. All right, then the other thing is, there's not always a one right way to do this. So here's a couple different ways I could lay out the same data. So on the left side is this figure where we were homing in. That was a pretty good comparison, I think, where I can see that the blue is higher than the red, plotted versus peak ground acceleration. Depending on my message, this peak ground acceleration may or may not be important, right? It might just be the displacements that are important, and this was just some sort of other variant that is not critical. So I could think about, some alternate figure, and I could say, well, let me just pick a set of, peak ground accelerations here and take the blue and the red lines at each one of those values and just plot them versus each other. So here's alternative 1 maximum displacement versus alternative 2 maximum displacement. And it's a little light on the screen, but there's a line with a slope of 1 to 1 right through here. And then what I've got plotted in the black line is just the paired values at each peak ground acceleration plotted versus each other. So I can see that down at maximum displacements of less than a half meter, the two lines are similar to each other. And then above a half meter, the black line has moved above the diagonal, indicating that the alternative 2 displacements are bigger than the alternative 1 displacements. Okay? So that would be another way for me to use the same data as the left figure, make a comparison between alternative 1 and alternative 2 displacements, and drop the peak ground acceleration out of the figure completely. Now, it's not clear to me that that's preferable, because it depends a little bit on what message I'm trying to tell. But the point is, you might iterate through a few different designs of a figure, and then come back and say, okay, well, I still like figure, the left figure, but I tried some other things just to play around with it and see if there's something else. Okay. Another way that we can make comparisons is by repeating a figure. And so I like to use repeated figures where I'm using exactly the same figure format. So here's an example of, so I have some sort of functional form I'm trying to plot. And so equations get a little tricky. We'll return to that in a moment. And so if I want to plot this function, I could plot this phi function versus tau. And then I could have 3 separate plots and just label it and just say this is increasing omega, right? Where that's some variable in the formula. I could say, okay, well, as omega increases, here's what that function looks like. And I really like these repeated figures for a couple of reasons. One is that you don't have to re-explain the figures. As soon as you know what figure the top figure is plotting, so I just said, this is this phi function versus tau, then you immediately know what the middle and the bottom figure are because it's identical, right? And the other thing is that it's really nice for comparisons, right? So I can see that as omega increases, the oscillation in this function is increasing, and I can see that this function is kind of decaying down to this horizontal axis more quickly as a function of tau at the bottom than it was at the top. Right, so kind of relative changes are pretty easy to see, and I don't have to explain 3 figures. I can just explain kind of the first figure. So think about if there's some sort of repetitive figure format that might work out, right? And in a way, this is similar to the line plots where I was stacking data. Right, so I had the red line and the blue line on the same figure. But in a case like this, where maybe it gets a little too busy, this is a case where I think it would probably be kind of a busy figure if I tried to stack all 3 of those lines onto one figure. In such a case, maybe just plotting the figures repetitive like this is an alternative strategy. Another thing to think about in terms of laying out your figures and the elements and things like that is animation. And I would say, we talked about in part 1 of this presentation, in general, I use animation very sparingly. I think it can generally just be distracting rather than helpful. Sometimes if there's a multi-step concept or some sort of complicated concept, I would consider animating in elements. So this was a slide I used a few years ago that was one case where I thought about using animation, so I figured I'd bring it up. So I had some sort of an equation down below. It doesn't matter too much. The input to the part of this equation was coming out of the data in this figure on the left. And I said, okay, well, so I've got this data. So here's a scatter plot with circles, right? And so I've collected up a bunch of data. And it's this SAA parameter versus a max inner-story drift ratio. And then I say, okay, I can superimpose some probability density functions here and then talk about how the data would be used to estimate these probability distributions. Superimpose a dashed black line as some sort of threshold. And then say, okay, well, the shaded area in these fitted distributions is the probability of exceedance that I'm interested in for my bottom formula. Right? And so that's a case where, maybe introducing the data and the distribution fit and the probability all at once might be a lot to kind of explain through. So you might think about layering in some animations to explain it in some details. I tend to do that sparingly, though, so don't necessarily think about that as your first option. Okay, let's talk about a couple other elements that can be graphics in technical presentations. So one is a flow chart. And I would say with all these other elements, we just have to use them cautiously and be careful that we're doing something smart. So here's two examples of flowcharts. Both of these were actually primarily designed for technical papers rather than presentations, but they serve some discussion here. So I'd say in general, a flowchart can be useful if you're trying to illustrate some sort of a complex relationship, that there's a lot of kind of inputs and outputs, and especially if you're trying to highlight, some particular part of the calculation that's the focus for your discussion. So this left figure, I would say this is about the simplest figure that I would consider using, because it's pretty close to just being a list, right? So the flowchart generally just flows from top to bottom, and there's, on the order of 7 different boxes here. And so it starts raising the question, why don't I just list 7 steps in a numbered list, right? If it's just flow from one thing to another. The only thing is that there were some kind of iterations shown with these dashed black lines that maybe are worth discussing about. You have to go back a little bit. And so discussing those iterations might make it worthwhile to have a flowchart like that. The right-hand side, so if the left-hand side is about the simplest chart I would consider using in a presentation, the right-hand side is about the most complex that I would consider using. So that's certainly a much more complex chart. It's got more complex, inputs and outputs. So it's certainly not just a list. In this case, actually, the gray circles serve to indicate some areas of focus in a paper. So I think it's worked very well for that, to talk about the white circles being kind of existing models and the gray circles being some added models. So that works pretty nicely. But if I was to show something like this in a presentation, I would really want a knowledgeable audience that had some familiarity with some of these steps. I guess as well, there's some kind of circles around here to talk about the stage 1 analysis, stage 2, stage 3, and kind of how they fit together. So if I had an audience that was pretty comfortable with one stage of this analysis, and I was saying, well, let's add stage 2 in here, then it might work. But if it was a novice audience, I think that would be pretty ambitious to try to go with some flowchart. So there's kind of a sweet spot, right? It can't be such a simple flowchart that you could just say it with a few words, but you don't want it to be so complex that the audience is kind of lost in terms of what you're doing. So just think about your message a lot if you use a flowchart. Another element that can be sometimes used as graphics is tables of data. So here's a potential table. If I was to put something like this in a presentation, I would be pretty cautious about doing it. And really, it gets back to what's my goal, what's my message. That's almost always the measuring stick you can use to decide if you're doing something good here. So I could think of a couple potential places where I might consider doing something like that, right? So I might use a table to highlight a few interesting numbers. So here, this is actually it's a list of earthquakes. So these are event name, and there's some data about them. And if I wanted to highlight, the maximum value of the number of stations was 616, I might use something like that. The other thing I'll, on rare occasions, do is to have a table to be almost like a background image or something, just to point out that data is available. Right? So if I had if I had this up, I might say, something like, oh, there's only 4 earthquakes in my data set that have more than 400 recording stations. Right? So you can only see that, the top 4 have more than 400, and then the rest of them have less than 400, right? So I could still say that in words, but maybe the table helps make that a little bit more concrete. And then the other thing I might do is to say, well, here's this table of this analysis I produced, and the actual data are available at this following URL, right? So there, my goal would be to just make the audience aware that some data set exists. And if I do my job and get them, excited about that data set, and I point them to where they can get it, then I've put the table up there merely as kind of advertising for some kind of later calculations. But if I want them to kind of understand all these numbers in this table, that's probably a bad strategy. I can't think of a case where that would be a good goal to have in a presentation. Another visual element that goes into technical presentations are equations, right? And so in papers, especially in reports, equations are critically important, right? Because then we need that equation in order to implement, the calculations you've done, or we need the equation to understand the assumptions or the strategy you've taken in doing your analysis. And in a paper, an audience can stare at that equation for a long time, right? They can look at it for 5 minutes. They can look at the definitions of all the variables. They can try to write the equation into a computer and try to implement it and see what happens. In a presentation, they don't have any of those options, right? They're going to look at that equation for not very long. They're not going to be able to try to implement anything. They're not necessarily going to have all the variable definitions that they're handy. And so, the notation part especially can be really tricky. And so I think it's risky to have, the equations without some thoughtfulness behind them can be tricky, right? So here's a couple of strategies that I like to use for equations. So one is that if I've got an equation, if I compare it with a graphic, then things will work out nicely, right? So I can, if I have an equation and then I say, okay, well, let's plot this equation versus t, and then I've got lambda as a parameter. Let me show you a plot for a few different values of lambda, right? Then graphically, I can kind of see what's going on with that equation. So that helps me to understand the equation. And then conversely, if I just had the figure without the equation, it might be kind of less clear to the audience where those numbers are coming from. So maybe the equation helps the audience understand why the figure looks that way. So a paired graphic and an equation can be a good strategy. A second strategy that I sometimes like to use for equations is to basically use it to just show like the ingredients for your calculation, right? So I might have some equation like this down below. And I'll say, okay, well, this is a calculation I'm trying to do, and let me explain why the left-hand side is interesting. And then here's my calculation. And I'm not showing you as the audience my equation because I want you to fully understand this equation. I want you to understand what are the inputs, right? What ingredients do I need to calculate the thing on the left-hand side, right? And so in a case like that, I'll do this type of annotation where I just draw arrows and point to different things, right? And so if I say, oh, well, for this calculation, I need a ground motion model and I need some site properties. So let's talk about ground motion models and site properties. And then you'll understand like why am I talking about those topics, because you understand that it's needed as an input to this equation. So that stops short of kind of fully digesting this equation, unless this equation is super number one most critical thing in my presentation. Usually that's not the case. Usually I'm trying to illustrate some concept, and you would show an equation like this to highlight, yeah, this thing is interesting for us. So that's why I'm gonna talk about this, so I can use it as input to this equation. When I'm doing this, I think it's really effective to use arrows and text labels to help with the notation, right? Because there's all sorts of variables usually in these equations. And if I give you a list down below of what those variables are defined as, that's kind of like giving you a legend on a figure. Now you've got to look back and forth from the list to the equation and figure out what's going on. Whereas if I directly annotate, it's much quicker. Even worse is to not define all those variables. I think there's almost no cases where it's where it's appropriate to give an equation without defining the variables. Because if their audience doesn't know what those variables are, what's the point of even showing them the equation? Right? The only time I can think of where people, the reasons why I think that sometimes happens is, one, the presenter is they're so fixated on their own perspective that they don't even stop to think about whether the audience, is going to need to know the definitions of all those variables. Or maybe they're trying to show off that they've got this cool equation they came up with, and they're more focused on kind of showing off their equation than they are of like having the audience understand kind of what the implications are. So in short, really, be careful about showing equations without some kind of clear labeling or some sort of accompanying graphic, something like that. So if you're just going to flash up a big set of equations like this, where I've got some sort of formula and I've got all sorts of variables, and I'll just define all the variables down below. I think this can be appropriate if the focus of the presentation is really, on this, how did you set up this equation and what's the goals? And if you're going to talk about this for a while, and you're specifically going to call out a couple of variables that you want to focus on, maybe that can be useful. But just showing the equation with a bunch of variable definitions, I'd say, be cautious about that, because it may turn out badly for you. Okay, so let's start heading towards conclusions. So hopefully I've given you some kind of ideas to think about, and my sense is a lot of people, if they were just aware of some of these concepts, they'll do a much better job. I know there was a lot of different ideas that I sprinkled through these slides. I would say having some sort of structure to your process can be really helpful. So this is kind of the thought process I use, or what I would suggest for you. And it's just 6 steps. This is the type of thing you could even just print out and leave on your desk, or save on your computer somewhere to take a peek at, and you can get through this one pretty easily. So again, remember, step 1 is, what is the message, right? What am I trying to convey with this graphic? You got to sort that out before you get going on it. Once you know your message, then you say, what type of figure is appropriate to tell that message, right? Line plot, scatter plot, something more unusual, a map, I don't know. Figure out what type of figure you want. And then what type of elements are going to be useful to tell that message, right? What am I trying to highlight? What things do I want the reader to compare between? And how can I use elements to help, make that clear? So after step 3, right, I've got a message, I've got a type of figure in my elements. Then I go back and say, okay, is everything clearly labeled, right? Check for acronyms, check for abbreviations, check for fonts that are too small, check for legends that are out of order with the lines, check if you can directly label things instead of using legends. Once you've done all that checks, and you make sure that things are labeled, then you can try it out, right? So use it in a practice presentation and get some feedback. And so I really like to, show these things in front of other people and get some feedback and say, is that clear what I'm talking about? Did you get that message? Is there something confusing in here? And sometimes it's eye-opening to say, well, I don't understand why you're plotting these two things against each other. Like, what's the point of this? Or, and if you can get feedback, that's great. And ultimately, like, that audience feedback is the most critical thing, because if they get the message, you can break some of the rules in here, you can do some non-standard things, but if the audience gets the message effectively, then great. Conversely, you could do everything perfectly, and if the audience is not getting your message, then you just got to stop and think, well, why not? What do I need to change so that they can get that message? And that's really the final verdict on whether you've done a good job or not. Okay, a few other concluding thoughts. So big picture, I think a little bit of care and thought can really improve the effectiveness of your graphics, right? That process on the previous slide is not very time consuming, right? It's really just about being thoughtful of how you go about doing these things. So with this process, it's not hard. It's just a matter of putting some structure to the way you're going about doing this work. And then finally, I'll close by saying, these are relatively basic things. I think in the scheme of visual design, there's people who've devoted their careers to these types of issues. There's people who've done research on cognition and how well people perceive things and how fast they process messages. A few books that I think are quite useful are listed here. I think this Now You See It by Stephen Few in particular has some really interesting thoughts about kind of elements of graphics and how to go about constructing graphics and using colors and lines and weights and things in an effective way. Nathan Yao has a kind of similar scope in his, and then an older book, 20 or 30 years old now, by Edward Tufte, is kind of a classic. It's an interesting one because it's kind of an interesting story, but I think it's much less clear and less up to date with kind of modern graphics tools and things like that compared to the top two. So I think those are roughly in order of my order of recommendation. But if you're interested in learning more, those are all useful tools for you. They're useful references for you. Okay, so that wraps up part 2 of this presentation sequence. I hope you got some good ideas out of here. I hope you left convinced that being thoughtful about this can really increase the effectiveness of your presentations. And I hope I get to see some great graphic elements in some of your future presentations and get to enjoy them.